Hey, welcome. This is the grade boost tutorial. For test 2, Math 0110. Comment, your questions are in different order. They're also different, not exactly like these. They have different numbers and slightly different configuration. And the second point is that I recommend you make notes from this. Make notes, written notes, solutions on your own based on this file. So have something handwritten. Don't just watch. You can't watch math and hope to learn it. You have to do math to learn it. And at minimum, that means writing it down. Let's launch into this. We have the first question. And let's try to get it done in 30 minutes. First question, the total mass of muffins on Mars, oh no, is modeled as m equals 0. Just kidding. M equals 2p squared minus 3p cubed plus 5v, where all those things are functions of time, and the quantities going into this model include pounds of pancakes on Pluto, which is currently 10 and is increasing, or rather decreasing, -2. So something's eating the pancakes on Pluto. The volume of vodka on Venus is currently 5,000 units. And the mass of muffins on Mars is currently decreasing such that m prime is equal to -1,600. Determine the rate of change of the volume of vodka on Venus. Okay. Sounds perfectly normal. We'll start this perfectly normal sounding problem by taking the derivative. Treating each of these as functions, because it says that they're functions of time, so we have to take implicit derivatives. Derivative of 2p squared is 4p to the power of 1 times p prime. Derivative of 3p cubed is 9p squared times p prime. Derivative of 5v is 5v prime. Now we can sub in the data. It says that m prime is -1600. It says that p is 10. It says that p prime is -2. Okay, and I'll sum in the same data here. I got 10 squared times -2 plus 5 times v prime, and v prime is the thing we want. We want the rate of change of the volume of vodka on Mars. -1600 equals, we have -80, and then here 900 times, so 1800 positive, plus 5v prime, and then, yikes, some big numbers. So I'm going to subtract 1,000 from both sides. Well, first subtract 800 from both sides, so -2,400, -3,400, -3,400 is equal to -80 plus 5v prime. I'm going to add 80 to both sides. -3,320 is equal to 5v prime. Then I have to divide both sides by 5, so I'm going to cheat. I'm going to divide both sides by 10 and then multiply by 2. So -332, and then I'm going to multiply that by 2, so 664. How to do math without a calculator? Maybe. I may have made a mistake doing adding, multiplying, subtracting, and dividing. Please check. The process is correct though. Next question. Find the slope. So find the slope of a tangent line. That immediately means y prime evaluated at somewhere. In this case, it tells us to evaluate at 5, -2. To do this, we need to take the derivative of all the pieces. The first part, the derivative of y to the 3 is 3y squared y prime. The second part, derivative of x to the 3 is 3x squared. equals. We have a product rule for the next part, and it's easy to miss if you're not looking for it. A times b, so ab prime plus ba prime. Next piece we have derivative of 3x is 3, derivative of negative 4y is negative 4y prime, and the derivative of 6 is 0. Now I'm going to plug in the product rule piece. 3y squared y prime plus 3x squared is equal to a is x squared times b prime is 2y y prime. ba prime, we have y squared times derivative of x squared, so 2x times y squared, plus 3 minus 4y prime. Next step, we need to reorder these terms so that all the y prime pieces are on the left, the pieces without y prime are on the right. So 3y squared y prime stays where it is. I have to subtract 2x squared y prime from the right to bring it over to the left, and I have to add 4y prime to bring it over to the left-hand side, equals the 2x y squared stays, the 3 stays, and the 3x squared has to be brought over. So I'll subtract it from both sides. Now I'm going to common factor y prime from the left-hand side. Right-hand side's already good. Nothing can be done to make it better. Now I'm going to divide both sides by that bracket. So 2xy squared plus 3 minus 3x squared divided by this stuff. I'm just going to copy it all. Okay, now we're ready to plug in the values. I'm going to make sure everything was copied down correctly. Okay, well, that's probably right. Now m equals, I'm going to plug in 5 for x, so 2 times 5, and negative 2 for y, so negative 2 squared, plus 3 minus 3 times 5 squared. Uh-oh, this is going to be a big number. Divided by 3 times negative 2 squared minus 2 times 5 squared times negative 2 plus 4. Let's see what happens. We get 1040, the first part, plus 3 minus 75, all divided by 12, and then 5 squared times, so 5 squared 25 times 2 times 2, 100 plus 4. So what we will get is negative 32, I think, 43, so 70, yeah, 30, negative 32, and then divide by 116, and then we can divide top and bottom by 2, we'll get negative 16 divided by 58, and we can divide that by 2, negative 8 divided by 29. Okay, next question. Oh. A bird has a height above an empty swimming pool given by h of t equals all that stuff for t greater than 0. At what time t does a bird have an acceleration equal to 5 over 12? Acceleration is a code word. It means we're going to find h double prime of t, and acceleration equal to that, we're going to set h double prime of t is equal to 5 over 12, rearrange and solve for t. I'll start by taking the first derivative. The derivative of 1 over 12 t squared, the 2 comes down. 2 over 12 is 1 over 6 t. Then we have plus. The 3 over 2 comes down. We have 3 times 4, 12 divided by 2, so 6 t to the power of 1/2. Power gets reduced by 1. Now we do it again. H double prime. Derivative of 1 over 6 times t is just 1 over 6. Derivative of 6t to the 1/2. The 1/2 comes down, multiplies by the 6, we get 3. And then the power gets reduced by 1 again, so negative 1/2. Then I'm going to set this equal to 5 over 12. And I'm going to rewrite t to the negative 1/2 as the square root of t using the rules of exponents. We need to rearrange and get t all by itself. So I'm going to subtract 1 over 6 from both sides. 5 over 12 minus 1 over 6 equals 3 over the square root of t. Then we have to make the common denominators. So I can multiply top and bottom 1 over 6 by 2. We get 2 over 12. And then I'm running out of space, so I'm going to go up here. 5 minus 2 is 3. So I have 3 over 12 equals 3 over the square root of t. The 3's cancel, but I'll do that in the next step. I'll cross multiply first. 3 root t is equal to 3 times 12. Now we can cancel the 3's. So square root of t is equal to 12. Now I'm going to square both sides. Square root of t all squared is equal to 12 all squared. So t equals 144. Next question, we're told some information. 2 to the power of a is equal to 4, ln of b is equal to -2, k is equal to 4, and then it asks, based on all that information, simplify 2 to the power of ka plus 4 to the a plus the ln of 1 over b to the k. We need to transform the components we have so that we can use the information that's given. First step in this transformation, I'm going to use the rules of exponents to rewrite 2 to the ka as 2 to the a all to the power of k. Because a power to the power multiplies, well, I can unmultiply those powers. Next step, I don't have 4 to the a, but I do have 2 to the a. And as an intermediate step to being able to use that piece of information, I'm going to rewrite 4 as 2 squared. And then for the last piece, I'm going to use a rule of logs that says the log of m over n is the log of m minus the log of n. So this is going to be the ln of the top minus the ln of the bottom. And at this point, we could have plugged in k, but I'll keep going. 2 to the power of a is 4, and I'll put k here still. I'll do that next. Then we have 2 to the 2 all to the a. Well, that's the same thing as 2 to the a all to the 2. Since a power to the power multiplies, I can multiply them in a different order. Ln of 0 is 1. Log any base of 1 is always 0. And the next part, you use another log property that says the log of m to the power of n is n times the log of m. So I have k times the ln of b. I'm just going to put a little division in here. These are the rules that we're using. Okay, now let's plug that k in. 4 to the power of 4. Oh no, big number. My mistake. It's okay, we'll live. 4 to the 4 plus 4 to the 2 minus 4 times the ln of b. Ln of b is -2. Okay, now we got to simplify. 4 to the power of 4. 4 times 4 times 4 times 4. 4 squared. 4 times 4 is 16. -4 times -2, positive 8. So we have 4 times 4 is 16 times 4 is 64. So 64 times 4 plus 24. So that's going to be 256 plus 24. So plus 460 plus 2080. So 280 would be the answer. Next question. Log properties. So this isn't a full question. It's a little bit of a hint of how to do a full question. If you're asked about which of the following statements is true, and the statements are all about log properties, you have to be able to justify the statement based on the log properties in order to say that it's true. So all the log properties are shown here, including the cancellation law, or one order of the cancellation law, log base b of b to the m is equal to m. And then statements like log base b of b is 1, log base b of 1 is 0, and some warnings at the bottom for things that you might be tempted to do with logs that you can't do with logs, like to distribute a log across a plus or a minus. So log of b plus n or b minus n, you can't rewrite that as log of the first plus or minus log of the second. Another one that's commonly misused is log of a ratio, or a ratio of logs. Log of something divided by log of something else, you can't write that as the log of the insides. So the log of the top divided by the bottom. As some examples, we can use the first, not the first rule, which rule can we use? We can use this rule, we can use the cancellation law here to cancel these and say that log base 3 of 3 to the a is equal to just a. We can also use the cancellation law this way. Log base a of a to the power of 3 is equal to 3. All that matters is that the base of the log and the base of the exponential function match, and then you can cancel them. The next one does not cancel. Log base 3 of a to the power of 3 is 3 times log base 3 of a, which is not equal to a. Cannot cancel. Okay, next rule, nothing can be done for the next one. No simplifications. You can't bring the a down, you can't bring the b down, you can't split it up. And the next one, you might be tempted to bring the 3 down, but you can't. The rule, log base b of m to the power of n, bringing the n down, you can only do that if everything is raised to that power together. So you can't bring the 3 down, no simplification. But you can simplify the next one. So for the next one, we would use this rule, bring the m down, and we have log base 3 of a plus b. So we have to be able to justify any simplification by using one of the log properties. And it's nice to have all the log properties in front of you when you're doing this, utilizing the fact this is open book. Next question, solving for x. So there's a few versions of solve for x problems with exponential functions. This is one where we have to make the bases match first. I can't easily write 27 as 9 to a power. It's possible, but it's easier to convert both powers to be the same, or both bases to be the same. I'm going to rewrite 9 as 3 squared. I'm going to rewrite 27 as 3 cubed. And then use the exponent property. If you have a power to a power, the powers multiply. So 3 to the power of 2x is equal to 3 to the power of 6x minus 9, making sure that that 3 gets both pieces upstairs. Now the powers must be equal since the bases are the same. I'm going to subtract 6x from both sides, so negative 4x is equal to negative 9. And then x is equal to 9 over 4, the negative signs cancel. Next question. We have a scary looking function. F of x is a bunch of stuff all raised to the power of 5, negative 2x plus 19. G of x, power 5. So g of x is unknown, it's a mystery function, but we do have some information about the mystery function. We know that g of 10 is equal to 1 and g prime of 10 is equal to negative 1. The question wants us to find f prime of 10. I'm going to start not by taking the derivative, but by recognizing what type of function this is. This is a function of the form w to the power of 5. It is a chain rule, a function to a power. When we take the derivative of w to the power of 5, we get 5w to the 4 times w prime. For this particular function, this will look like negative 2x plus 19 times g of x. All of that is raised to the power of 4 multiplied by w prime. I'm going to do w prime stuff off to the side. W is equal to negative 2x plus 19g of x. So then w prime is going to be negative 2 plus 19g prime of x. This is like taking the derivative of y, or 3y. Derivative of 3y is 3y prime. Derivative of 19g is 19g prime. Uh-oh, don't do that. So I'm going to plug that in the box here, negative 2 plus 19 g prime of x. Next is evaluating at 10. It wants f prime of 10, so I'm going to replace all the x's with 10 everywhere. So 5 times negative 20 plus 19 g of 10, power 4, negative 2 plus 19 times g prime of 10. And then we got to plug in the data from the question. Negative 5, 20 plus 19, power 4, negative 2 plus 19, leave a space. Now plug in the data. G of 10, it says, is 1. G prime of 10, it says, is negative 1. So we're going to get 5 times negative 1 to the power of 4 times negative 21. So 5 times 1 times negative 21, we're going to get minus 105 as our answer. Okay, next question, we're told that 3 to the power of 4 to the 3 times 9 to the power of k divided by 3 to the power of 5 is equal to 3 to the power of 10. You want to solve for k. There's many ways to do this. You could, if you're a glutton for punishment, raise 3 to the power of 5. And then raise 3 to the power of 4 to the 3, so 3 to the power of 12. Get like gigantic numbers everywhere, 3 to the power of 10. Start dividing and multiplying, but that's not a very good way to go. Let's try to use exponent laws to do this. 3 to the power of 4 all to the power of 3, we can use the law of exponents that says a power to the power will result in the powers multiplying, so 3 to the power of 12. The next one's a bit tricky. We can't directly proceed unless we convert 9 into 3 squared. Make the bases all the same so we can use the laws of exponents. And then I'm going to do something in the same step. I'm going to rewrite this 3 to the 5 downstairs as a 3 to the negative 5 upstairs. So I'll use a bunch of exponent laws on the left-hand side. Next, I'm going to simplify a little bit before doing the next step. 3 to the 2k, multiply the powers together. Okay, and now we have a bunch of terms all with the same base multiplied together. The bases are all going to add. So 3 to the 12 plus 2k minus 5 is equal to 3 to the 10. And that means all the base two powers equal the same base to a different power. It means the powers are equal. So 12 plus 2k minus 5 equals 10. So I'm going to subtract 12 from both sides. I get negative 2. Add 5 from both sides. I get 3. So 2k is equal to 3. And that means that k is equal to 3 over 2. Another question, 2 to the x is equal to 16. There's a few ways we can do this. Here's one method. We could say that 2 to the x is equal to 2 to the 4, recognizing that 16 is 2 to the power 4, and that means that x is 4. Or, I'll say and, we could say, we could take log base 2 of both sides. Log base 2 of 2 to the x is equal to log base 2 of 16. So x is equal to log base 2 of 16. That would be 2 good answers. And there's more. Ln 16 divided by ln 2. So lots of good answers, many good answers. That is the worst y I've ever written, today at least. So I'll ln both sides. Ln of 2 to the x is equal to ln of 16. But I can bring the x down using that log property that we used a few times. Then divide both sides by ln 2. So x is ln 16 divided by ln 2. Look at all the different ways you can write 4. You can write it as 4, you can write it as log base 2 of 16, and you can write it as ln of 16 divided by ln of 2. So you have to be able to recognize that these are all correct and equivalent answers. Okay, and then the last question. We're given information about log base 2 of a minus b and log base 2 of c plus b. We're told what they are, and then we're asked for something else. So what we have to do is we have to find a way to express the thing at the end, the log base 2 of all that horrible stuff. We have to rewrite it and express it in terms of what was given to us. So the first thing that I see looking at this is I can say that this is the log of a top thing over a bottom thing. It's a log of m over n, which we can rewrite as the log of m minus the log of n. I'm just being brief, not writing the base part down. It's true for any base. So this is log base 2 of the top, a minus b squared, minus log base 2 of the bottom. Now I'm going to rewrite this as c plus b to the power 1/2, just to save a step. Square root means power 1/2. It's not a very good 2, is it? Still not a good 2. I'll have to leave it now. Okay, next I'm going to use a property that we've used several times. This is the log of m to the power of n equals n times the log of m rule. So I'm going to bring the 2 down. 2 times log base 2 a minus b minus 1/2. Bring the 1/2 down. Log base 2 of c plus b. Now I can plug in the data from the question. Question says that log base 2 of a minus b is 5 and log base 2 of c plus b is 6. Just making sure I'm copying those right. So 10 minus 3, we get 7 as our final answer. That's it. So as a recap, we have a collection of problems here that require us to know our log rules and our exponent laws. So log, exponent, exponent. We have some questions that require us to know the chain rule. There's a general chain rule question where there's a mystery function. We have to use information about the mystery function to answer it. Another exponent law question, more log properties and exponent properties. We have a bird above a swimming pool that's empty. This is an acceleration question, or acceleration being a code word, find the second derivative. This one doesn't want us to plug a t value into the second derivative. It wants us to find the t value that results in a target acceleration. So we replace the acceleration by that number and rearrange and solve for t. The rearranging part's usually the hard part. Then we have a tangent line question that we did. Tangent line is a code word that means take the derivative and evaluate it somewhere. This is an implicitly defined function, so we have to take implicit derivatives. There's a sneaky product rule hidden in here. That's probably the most common source of error in a question like this one, would be to miss the product rule. And then there's, at the very end, plugging the numbers. That's kind of random. It's easy to make a mistake there, even if you know what you're doing. And then muffins on Mars. This is not very nice numbers, but hopefully this is right. There could be an error in there. I'm not too confident on that, all that adding and multiplying, but that's the process. Take the derivatives implicitly, plug the numbers in, and simplify the best that you can. Hopefully that's helpful. Hopefully this grade boosts your grade. It gives you a little bit of not just better marks, but better confidence in this material. That's it. See you next time, and we made it under 30 minutes. Yay.